Betelgeuse, the red supergiant star perched in the Orion constellation, has fascinated humanity for centuries. Visible to the naked eye as a brilliant, reddish point in the night sky, it has served as a celestial landmark for stargazers across cultures, from ancient Egyptians and Greeks to modern astronomers. For generations, people have looked to Orion's shoulder and wondered about the stories behind the stars. Yet, in recent years, Betelgeuse has moved from being a familiar fixture of the sky to the center of intense scientific investigation. Its erratic and unpredictable behavior hints that it may be approaching the end of its life, a spectacular finale that could one day see it explode as a supernova. To understand why Betelgeuse commands such attention, we first need to grasp its immense scale. This star is enormous, over 700 times the diameter of our Sun. To put that in perspective, if Betelgeuse were placed at the center of our solar system, its surface would extend beyond Jupiter's orbit, engulfing Mercury, Venus, Earth, Mars, and the asteroid belt entirely. And despite its size, Betelgeuse is relatively nearby, at just about 650 light-years from Earth. That distance is close enough that a supernova here would be visible with incredible clarity, even during daylight, making it one of the most anticipated cosmic events for humanity. The fascination with Betelgeuse intensified in late 2019 when the star underwent a mysterious and dramatic dimming, which became known as the Great Dimming. Its brightness dropped to nearly 40% of its usual luminosity, a change so pronounced it could be seen even by casual observers with no telescope. This caused a wave of excitement and speculation among astronomers worldwide. Was Betelgeuse signaling its impending death? Could we be witnessing the early stages of a supernova within our lifetime? Astronomers turned the most advanced observational tools toward the star to uncover the truth. The Very Large Telescope, VLT, in Chile, one of Earth's most powerful optical instruments, captured high-resolution images of Betelgeuse's surface. What they found was astonishing. The star had become asymmetrical and distorted. The most plausible explanation was a massive ejection of its outer material, a surface mass ejection, or SME, forming a dense cloud of gas and dust that temporarily obscured its surface. These events are similar to solar flares on our Sun but on an incomprehensibly larger scale. Scientists estimate that Betelgeuse expelled over 400 billion metric tons of matter in this single outburst, marking an unprecedented phenomenon for a star of its type. The star's pulsation cycle, the regular swelling and contracting of its outer layers, also underwent a dramatic change. Before the Great Dimming, Betelgeuse's cycle lasted approximately 400 days. Afterward, it shortened to roughly 200 days, a clear signal that the star's internal dynamics had been significantly disturbed. But this wasn't the only unusual activity. In 2023, the James Webb Space Telescope, JWST, provided further insight. Observing in the infrared spectrum, the JWST could peer through the dust clouds surrounding the star and analyze the ejected gas. The telescope revealed signs of rapid internal collapse, disrupting the fusion processes at the star's core. Betelgeuse was no longer pulsing with its usual rhythm. Its surface activity had become increasingly chaotic. These observations are more than intriguing, they are historic. Massive stars like Betelgeuse live fast and die spectacularly. As they exhaust their nuclear fuel, they begin fusing heavier elements in their cores, eventually producing iron. Unlike lighter elements, iron fusion consumes energy rather than generating it. Once the core accumulates enough iron, it can no longer support itself, collapsing under its own gravity in seconds. The result is a supernova, a cataclysmic explosion that can outshine entire galaxies for weeks. Betelgeuse is very likely on this path, and recent changes suggest it may be edging closer to that fate. While predicting the exact timing of such an event is impossible, scientists have narrowed estimates to somewhere between 10,000 and 100,000 years. Some researchers argue that the dramatic dimming, mass ejections, and core instabilities could indicate that the explosion might occur much sooner. Unlike earthquakes or hurricanes, stellar deaths cannot be forecasted with precision. But astronomers have devised ways to anticipate signs of an imminent supernova. One of the earliest indicators is a surge of neutrinos, tiny, nearly massless particles that escape from the star's core just before the visible explosion occurs. These neutrinos pass through matter almost unimpeded, carrying information about the processes happening deep within the star. Detectors like Super Kamiokande in Japan and IceCube in Antarctica continuously monitor for any unusual bursts of neutrinos from Betelgeuse. Should these particles spike, astronomers could gain hours of warning before the star's final blaze lights up the sky. When Betelgeuse does eventually explode, it will be a cosmic spectacle unlike anything most humans have ever witnessed. The explosion would likely outshine the full moon, casting shadows at night and remaining visible even during the day for several weeks. For scientists, it would be an unprecedented opportunity to study the death of a massive star in real time. Data collected from the supernova would provide insights into how elements are forged in stellar cores, how stars collapse into neutron stars or black holes, and how energy and matter are expelled into the surrounding galaxy. Although Betelgeuse is relatively close in astronomical terms, the supernova would pose no danger to Earth. Its radiation would not reach harmful levels at this distance. Instead, it would illuminate the processes that shape galaxies and seed the universe with the heavy elements, carbon, oxygen, iron, that eventually form planets, and even life itself. Understanding these processes could shed light on the origins of our solar system and the very building blocks of life. Betelgeuse's proximity also makes it an extraordinary laboratory for studying late-stage stellar evolution. Most stars die far from us or over timescales too long to observe directly. But Betelgeuse allows astronomers to watch the dramatic, final stages of a star's life unfold in unprecedented detail. Using data from the JWST, the VLT, and other observatories, scientists are building high-resolution models of the star's internal structure. Simulations reveal unstable convective currents and turbulent cavities of hot gas, likely responsible for the recent dimming, brightening, and mass ejections. Betelgeuse is far more than a red point in the sky. It is a dynamic, evolving system, a living laboratory for understanding the forces that govern the cosmos. Each flare, each pulse, each ejected cloud of gas provides critical clues about how massive stars live and die. The star's unpredictability has sparked global collaboration among observatories, satellites, and researchers, all racing to monitor its every subtle change. Even beyond the scientific community, Betelgeuse has captured the public's imagination. News reports, social media discussions, and educational programs have turned this distant star into a symbol of cosmic wonder. The possibility of witnessing a supernova in our lifetimes connects humanity to the vast universe in a deeply emotional and visceral way. It is a reminder that we are not merely observers of the cosmos. We are participants in a universe that is alive, dynamic, and interconnected. One day, Betelgeuse will vanish from the night sky in a blaze of supernova brilliance. But until then, scientists and skywatchers alike will continue to observe, measure, and learn. Every flicker of light, every puff of gas, every subtle shift in pulsation brings us closer to understanding the life cycles of stars. When that ultimate explosion occurs, it will illuminate not only our night sky but also the cosmic processes that shape galaxies, forge planets, and give rise to life. As we gaze toward Orion's shoulder, we are reminded that one of those glowing points is far more than a star. It is a story unfolding in real time, a spectacular cosmic event in the making, and a living testament to the mysteries and wonders of the universe. Betelgeuse is not just a star. It is a glimpse into the profound forces that shape existence itself, a dazzling, unpredictable reminder that the cosmos is full of surprises, and that we are fortunate witnesses to its grandeur.